Cloud Service Models. IaaS. Infrastructure as a Service, IaaS, is likely still the best no-service model of cloud. Typically, enterprises still start with IaaS when they initiate the migration to cloud providers. In practice, this means that enterprises perform a lift and shift of their virtual machines to resources that are hosted in cloud. The cloud provider will manage only the infrastructure for the customer, network, storage, compute and the virtualization layer. The latter is important, since customers will share physical resources in cloud. These resources, for instance servers, are virtualized so they can host multiple instances. PaaS. With platform as a service, cloud providers take more responsibility over resources, now including operating systems and middleware. A good example is a database platform. Customers don't need to take care of the database platform, but simply run a database instance on a database platform. The database software, for example SQL, is taken care of by the cloud provider, including the underlying operating systems. SaaS. Software as a Service, SaaS, is generally perceived as the future model for cloud services. It basically means that the cloud provider manages everything in the software stack, from the infrastructure to the actual application with all its components including data, software updates, bug fixes, and infrastructure maintenance are all handled by the cloud provider. The user, who typically uses the application through some form of subscription, connects to the app through a portal or API without installing software on local machines. FaaS. Function as a Service, FaaS, refers to a cloud service that enables the development and management of serverless computing applications. Serverless does not mean that there are no services involved, but developers can program services without having to worry about setting up and maintaining a server. That's taken care of by the cloud provider. The big advantage is that the programmed service only uses the exact amount of, for instance, CPU and memory, instead of an entire virtual machine. CaaS. A growing number of enterprises is adopting container technology to host, run and scale their applications. To run containers, developers must set up a runtime environment for these containers. Typically, this is done with Kubernetes, that has developed to an industry standard to host, orchestrate and run containers. Setting up Kubernetes clusters can be complex and time-consuming. Container as a Service, CaaS, is the solution. CaaS provides an easy way to set up container clusters. XaaS. Anything as a Service, XaaS, is a term used to express the idea that users can have everything as a service. The concept is widely spread with, for instance, hardware as a service, IaaS, desktop as a service, DaaS, or database as a service, the BaaS. This is not limited to IT, though. The general idea is that companies will offer services and products in an as-a-service model, using cloud as the digital enabler. Examples are food delivery to homes, ordering taxis, or consulting a doctor using apps. Cloud Vocabulary. CMP. A cloud management platform provides a platform that enables management across various clouds, public and private. It allows management with one single interface, instead of having to go through different cloud portals. It can help in provisioning services, metering and billing, and configuration management of resources that are deployed in various cloud platforms. Cloud native. This indicates that applications and software was particularly written for cloud usage. Host. This is the physical machine that sits in the data center of the cloud provider that hosts guest environments of customers. Remember the cliché, cloud is just someone else's computer. You are using it. Virtual machine. A virtual machine runs on the physical host, but acts as a complete server. Hypervisor. This allows a host machine to be able to run multiple virtual machines. The technology of hypervisor was essentially the start of cloud, since it allows servers to act as multiple servers. Best known hypervisor and market leader is VMware's vSphere, followed by Microsoft's Hyper-V, Citrix XCN and Red Hat Enterprise Virtualization. But there are many more. Hybrid. Typically, this is to indicate that a cloud platform uses both public clouds such as AWS or Azure and private clouds that run in the data center of the company itself or a third-party data center. Load balancing. If we run multiple resources such as servers, databases and storage spaces, we need a mechanism that divides the load over these resources. In cloud, we have many resources, some dedicated to a specific customer, but also a lot of shared resources. Load balancing is essential to spread traffic and data across the resources. Multi-tenancy. This is probably the most important term to remember in cloud. Image cloud as a big house with multiple tenants. These tenants will have a room for themselves, but also share facilities. Multi-tenancy indicates that software is running on shared components, where resources are dynamically assigned to software. Resource. This is the term that is used for components that are used in cloud to run applications, save data and execute services. A server is a resource. So is a database or a firewall. Scalability. Because of virtualization, shared resources, load balancing and multi-tenancy, cloud is scalable. Companies use what they need at a certain time. They can scale up when demand is high and scale down in more quiet times. This is the big advantage over environments in privately owned data centers, where equipment such as servers and storage cabinets are simply there, but sit idle when there is no demand for it. UI. The user interface. At the end of the day, operators and developers must be able to work with the resources in cloud. This is done through the UI. In most cases, a portal with all the services that can be deployed in a cloud platform. Having said that, most developers and operators use other mechanisms to manage workloads in the cloud, since a portal with a graphical UI is too slow for large-scale operations. Then scripting comes into play, for instance using command-line interfaces with PowerShell that can be used in Azure and AWS and G Cloud Command in GCP.